Hello everyone, we are going to see a very important topic in the optics, that is the resolving power of any optical instrument. In the optics, the various instruments such as telescope, microscope and other experiment optical instruments used to obtain the image of the object. This optical instrument, when we see the quality of the optical instrument, these optical instruments must have two refined quality, in which the first one is known as the magnification. In that, magnifying power. Second one is the good resolvability, that is the resolving power of optical instrument. Now let us see very carefully. The present topic is to study resolving power, but the concept of resolving power cannot be clearly understood until or unless we are not knowing magnifying power of optical instrument. For magnifying power, let us see very carefully. We are knowing the term magnification. Magnification gives the ratio between size of image to size of object whenever we make any image by using mirror or lenses or any other optical devices, in which if we use a lens or mirror, the magnification is denoted by m. It is ratio of size of image to size of object, or it is also v by u. We are knowing v is a distance between image to the lens or mirror, and u is the distance between object and the mirror or lens, whichever is used here in this case. Magnification, if it is 1, then both sizes same. Less than 1, it is called diminished size of the image than compared to size of object. If it is greater than 1, then it is showed as size of image is larger than size of object. Actually, this optical instrument is designed in such a way that its magnifying power must be greater than 1. So larger size can be obtained to see the clear view of the object. And you are knowing that optical instrument is used for that. But only magnification is not important. With magnifying power, resolving power is also very important. Resolving power becomes very important in case of a microscope when we have very closed up, too close object. Or we may say too nearby object. When we see too nearby object here in case of analysis of the structure of cell or any tissues structure, when we analyzed, so these cells are very close nearby. If they close in such a way that if you obtain magnifying and in that condition their intermingling image is obtained, then too nearby object cannot be clearly viewed. See why. One of the diagram I want to see to you. According to the concept, see this diagram very carefully, which diagram I want to show you. According to this, whenever we see any object, actually diffraction pattern of the object is formed on the retina, and principal maxima, zero order principal maxima, their intensity is maximum, and we see principal maxima on the retina. Now see here in this diagram where the pointer is two nearby very close object. When we see by optical instruments such as microscope, their magnified image formed, because magnifying power is compound microscope is very high. But two diffraction pattern is obtained and they're very close and in such a way that it become very difficult to see both separate images here because both overlap to each other. This type of image is called unresolved image. So optic resolving power is that how much both two separate nearby images can be made separately. So see in this diagram, both diffraction pattern is just resolved and here fully resolved. So their clear structure of the cell, if one student or researcher is observing, can see clearly by this. If he is doing that, then it can be said that the fully resolved and it has a good resolving power. Now see very carefully. Here in this diagram, what is that? We have three diagrams available. In the first diagram, both images are overlapped to each other. In that, see very carefully. What is that? Two objects, two central maxima, but both mixing with each other. So both combine and form a single maxima. That is why the single image is obtained. Two diffractions maximas. Now here what is done here? Both separated by this, right? And now it is fully resolved. When it is fully resolved, then see in the diagram, both central maxima of the diffraction pattern is separated. And if it is separated by the technique that is criteria, and that criteria is given by Rayleigh, that is why it is called a Rayleigh criterion to resolve two nearby objects. What is done in that? This is the central maxima of the first image falls over the first minima of another, whereas the central maxima or principal maxima of the second image is fall on the first minima of another. Then it is said to be resolved. This situation is measured and this is called Rayleigh criterion. So according to Rayleigh criterion, what is the Rayleigh criterion? Principal maxima. Principal maxima. What about the principal maxima? Principal maxima of one of image made fall over first minima of another diffraction pattern. Diffraction pattern mean image. And same thing is done. We are normally using a word vice versa. It's called Rayleigh criterion. In that criterion, the two nearby object is resolved. This property is called resolving power of optical instrument. So different optical instrument, microscope, telescope and grating has a different formula to determine this resolving power. An optical instrument is said to be good if it is good caliber to separate. What separate? Very important term, remember. Good for separate images. What separate? Images of two nearby objects. So this is for the topic. Thank you and have a nice day.